Okay, here's our second video. We pick up with question 4 since we went through question 3 in the first one. And in question 4, we have a life insurance company or some sort of financial services company that is offering an annuity. They're selling an annuity that pays 7.25% compounded monthly. And we are asked if we invest $500, if we pay $500 into this annuity every month, how much is going to be in that account after 10 years? Well, the after 10 years part tells us that this is a future value we're looking for. So we use the formula here for future value. And so this part of the calculation is going to be our future value. And then we'll subtract the total of payments to get the amount that is interest, because that's the second part of our question. So I have the keystrokes for a graphing calculator here. They are, there's a lot of them. And so I could see how it would be really easy to trip up and miss a stroke or put one too many or something like that. As a matter of fact, I did. When I used my calculator, I was able to calculate this with no problem. But when I used the PE3 so that I would be able to show you all of these keystrokes, I got the wrong answer a couple of times, and even though it doesn't really make sense to me, the way that I wound up putting these together, I discovered what I was doing wrong, and so these strokes, these exact strokes, would give you the correct final calculation, $27,743.35. Now, it should be said that to simplify all of this stuff, any of you, I think, are capable of multiplying 12 times 10 and getting 120, and so that would just be one value there instead of 12 times 10. And on the exam, even though 0.0725 divided by 12 doesn't divide out all nice and neatly, the numbers that I used on the exam do. So you can make, you can calculate your I, which is what this is right here. You can calculate your I ahead of time as well, and that would simplify the keystrokes. So in any case, for a graphing, you would enter 500 multiplication. The left parenthesis is for, or the first parenthesis is for the numerator. Then the second parenthesis is for this expression right here that is then going to be raised to this exponent. Excuse me. And so I close the parentheses here for this value, 1 plus 0.0725 divided by 12, because that's the rate, divided by the number of compounding periods per year. That is the I that's going here and here. And so I've closed the parentheses there, corresponding to this parenthesis. And then I raise it to the exponent 12 times 10. Well, now it shouldn't be necessary to have parentheses for these multiplications, but I believe the fact that I'm using this caret, as a matter of fact, it just dawns on me, the fact that I'm using this caret means that I do need to segregate out the exponent, so that when I then say minus 1, the calculator knows not to raise this figure to the 12th, then multiply all those calculations times 10. Of course, that's alleviated if you just multiply 12 times 10. You have 120, and you just use that as your exponent. Anyway, that's enough of an explanation for the numerator. We then close the numerator out with a right parenthesis, and then we divide by the denominator. We do need to put the entire denominator in parentheses for the sake of the order of operations. When you string together multiple multiplications or divisions, they have the same priority, and so the calculator will do them left to right. Whichever one comes first is the left, and then it'll proceed left to right. Anyway, so that's the denominator, and once you divide by that denominator, then from here, right here, all the way to the beginning, 500, that is one, that's going to be one figure. And so that's what you would need to, excuse me, that's what you would need to calculate to find this portion of the answer, the amount that's in the account after 10 years. Excuse me. So that's $87,743.35, and then the 60,000, and that's the total after compounding, and then the 60,000 is your total of payments, which is your payment times the number of compounding periods per year times the number of years, and that calculation is right here. It's very easy. 500 times 12 times 10. That's 60,000. You subtract that from the 87,743.35, and you get the amount of the interest. So that's the amount of the interest. And now let's take a look at the keystrokes for the scientific. Everything is the same, except here you segregated the exponent using parentheses. Here, remember, when you press this caret button on a scientific, it gives you the superscript. It pulls up a superscript, and every calculation you enter is going to stay there until you say, hey, let's get out of here. And the cursor to the right is the button that says, hey, let's get out of here. And so when you press that button, that brings you down to the main operation line, and you subtract 1 and close your parentheses, and that gives you your numerator. Everything else is the same. But those two ways of handling the exponent are different between the graphing and the scientific. Okay, and I feel like asking at this point, are there any questions? But of course, nobody can hear me, so there's not much point in that. If you do have questions, of course, text me at 464-5781. All right, now question 5 asks, how much should payments be? So the first question says, given the amount of the payments, what's the future value? The second, this question says, well, we're going to tell you the future value. How much do the payments need to be to reach that future value? And so this is the formula for payments given the future value and the interest rate per compounding period. Now notice, in the question, the future value is given, but so is the interest rate per compounding period. That is your I. You don't need to calculate it as you did in this question. I is already given to you. And so and the number of total number of compounding periods is 10. That is the N in this formula here. That's the N right here. And so here's the keystrokes for the graphing. So this is principal 2,500 times 0.08. And then you divide by the denominator. The denominator has to be segregated in a separate set of parentheses. And so this first left parenthesis indicates here's the denominator. And then this, these parentheses are for this figure right here, this value, 1 plus 0.08. Of course, as I've mentioned before, you are perfectly capable of adding 0.08 to 1 and entering it in as 1.08. But I've written it out completely, and I hope that doesn't add any confusion. And so there's the caret for the exponent, and 10 is the exponent because that's the number of compounding periods that we subtract 1 and close it. That's for the graphing. Now for the scientific, to get out of the exponent, we have to push this right cursor button, which I unfortunately forgot to indicate as a button press. So there you go, I made that change in the middle of this video. So everything is the same except right here you have to, once you take your entry line up into the superscript, you have to get out of it, you have to push the right cursor button on the scientific to get down to the base entry line. And again, you close the parentheses, hit enter, and so our payments are $172.57. So that's it for that question. Now, question 6 uses a graph. And while you could do this with your graphing calculator, it's going to be a lot easier if I provide that graph for you to look at and compare. It'll be a lot bigger than in the tiny little screen on your calculator. Plus, I have manipulated it so that the x values will be in percent. So they're not a decimal, they're a percent. So I provide on the test, as I did on the practice, some graphs to choose from. And here's one graph, and here's another. Which one should we use? Well, this is future value, and future value would increase. So as you put your payments in, your future value increases. And so that's going to tell us that we're not going to use the first graph since it's a decreasing function. We're going to use the second one because it's an increasing function. And there are other characteristics of the graph that we will discuss in class that will allow you to choose between two increasing graphs, but for the practice I only included a decreasing and an increasing. Well, what are we looking for here? Well, we want to know what rate per compounding period is going to get us to $12,000. And so if you look at the graph, you see that that y is dollars in thousands. Well, we want to know when this graph, we want to know when this future value function is going to reach 12,000. So what we do is, on our blank graph, we get a ruler and we draw the line 12, or we just look and see where this intersects $12,000. And it looks like it intersects it at 4.0 1, 2, 3, 4. 4.2. So each of these is 1/10. How do I know this? Well, because from 0 to 1, I have 1 hash, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so you'll need to be able to interpret the scale of the graph that you're given on the test. And so this is 4.1.2, and that's when it looks like it reaches $12,000. And so the answer is that the rate per compounding period is 4.2%. So that's it for the review videos so far. The other questions address present value, and that's a topic that will be covered Monday. And so sometime Monday I will upload a video for those questions, for questions 7 through 10.